Now let's talk about what to do over here. Basically, we're just going to break our compound down into its two elements and describe all the stuff that goes on in ionic bonding. From the number of valence electrons, to what it has to do with those electrons, to the final ion or charge you're going to end up with. Remember, valence electrons are related to group number. Group 1 has 1, group 2 has 2, group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. Basically, we're going to drop all the ones over here when we get to the teens. So we start off with beryllium, Be. Group 1, group 2. So it has 2 valence electrons. It's a metal. We know it's a metal because it's to the left of the metalloids. We know it's a metal because it has 1, 2, or 3 valence electrons. Metals will lose all their valence electrons in order to become stable. The ion is just basically what we wrote down over here when we looked up oxidation number. Because it loses 2 electrons, it ends up with a +2 charge. And we write that charge in the upper right-hand corner. Let's do fluorine. There's fluorine. Group 17. 7 valence electrons. It's a nonmetal. There's 2 ways we know it's a nonmetal. 1 is to the right of the metalloids. And 2, it has 5, 6, or 7 valence electrons. If it has 5, 6, or 7 valence electrons, it's a nonmetal. Nonmetals gain whatever they need to have 8, so this one is going to gain 1 more. When it does, it'll be a negative ion. It'll be written just like we wrote the fluorine over here, with that oxidation number, F with a -1 charge. And again, you can flip the sign in the number, so you could write that as 1 negative. Or you can leave the 1 off altogether and just write negative there for fluorine. If it's 2 or 3, you have to put the number there. You can't leave that one off. But you could write that as 2+ as opposed to +2.